Hello everyone. We discuss shift reagents in this lecture. So what is a chiral shift reagent? It's a special compounds that is used in the NMR spectroscopy. What is its useful? They are used to differentiate between isomers, that is enantiomers, present in a mixture. How? They will interact with the different isomers, that is enantiomers, at different rates. Therefore, we'll get different signals. Thereby, the shift reagent helps us to discriminate between the two different enantiomers. And sometimes it is also helpful to find the absolute configurations of the compound, as well as very often will be used to identify the enantiomeric excess present in the compound. It has to be read as small e. So what is enantiomeric excess? Let's presume we have a mixture that contains predominantly large R and few S, or small amount of S. Then when you add chiral shift reagents, then they will react with the R and S at different rates. Because R is present in the large excess, we presume that the relative intensities upon adding the shift reagents will be larger for the R over S. Therefore, we'll be able to discriminate between R and S. So that is how the shift reagents help. And I told you that it is helpful for identify the absolute configurations of the compound. So let's look into an example. So this is a spectrum. This is a spectrum of hexanol. However, the hexanol contains various protons and they appear too close, and therefore we are getting a unsplitted complex spectra. In other words, they are unresolved. Now, how to get a clear spectrum? Because obviously you cannot extract much information from this spectra. So when you add a shift reagent, what happens? When you add a shift reagents, as expected, they interact with the different protons at different rates. So literally they give different signals or splitting of signals. So thereby we'll be able to decipher much information about the protons present in the hexanol. Let us compare the difference of the spectrum before addition and after addition. So we are getting a very well defined spectrum out of the shift reagents. So this is the beauty of shift reagents, and these are some of the shift reagents, and it has to be spelled as, for example, this molecule spelled as tris di-5-valmenato europium salt, or simply europium DPM 3 times. So these are some of the shift reagents. Apart from that, we have europium FOD, and these are the reagents that will interact with molecules at different rates and helpful in discriminating the enantiomers. Thank you very much.